This is Scienceorzo. Today I'm gonna explain you how scientists isolated the electron from the atom. This includes cathode rays, properties of cathode rays, and famous scientists like J J Thompson, Stoney, and Faraday. So before we jump into that, let's go to the history of atom. What made them discover the electron? Democritus and some other Greek philosophers were the first to say matter was made up of small particles called atomos, which means indivisible. Then later, that name changed to atom. They thought that this atom was indivisible. Then something amazing took place in the field of science, the discovery of electric nature of matter. Scientists were amazed to see how matter show electric nature. Stoney, who was mesmerized by this fact, named the particle responsible for electric nature of matter as electron. So how did he do it? Let me give an example. Your blood is red, right? So what is the particle responsible for that red color? It's hemoglobin. So he thought the same, and he thought that there was some particle responsible for this electric nature. So he named it as electron, or atom of electricity. Later, a scientist known as Faraday conducted a series of experiments and finally calculated the charge of 1 mole of atom of electricity, which is 96,500 coulombs, also known as the Faraday's constant. Including Faraday, many other scientists conducted experiments in order to isolate electrons from the atom, but all this was a failure. Later, a scientist named Crook and 2 of his co-workers, Hitov and Plucker, began to study electrical discharges through a gas tube pumped almost in empty air. He named this as the Crook tube or discharge tube. It looks something like this. There are 2 electrodes on either side of the tube connected to a voltage of 20,000 volts. As it is difficult to get this amount of voltage, we use an induction coil. After reducing the pressure inside the tube to 0.01 mercury millimeters, the cathode produced a stream of radiations which was attracted towards the anode. Because they were produced at the cathode, they were known as cathode rays. In 1870, J J Thompson experimentally determined the properties of cathode rays. First, he placed the positive and negative plates on either side of the cathode tube and turned on the electricity. He was amazed to see how the rays bent towards the positive plate. This property of cathode rays made him to realize that they are negatively charged. Cathode rays have kinetic energy. This property was explained when Thomson placed the paddle wheel inside a tube by applying mica on it. So why did he apply mica on it? As mica is applied on paddles, it's able to clearly observe the rotation of paddle wheel with reddish orange color. He also proved that cathode rays move in straight lines. He did this by placing an object in the path of cathode rays. He observed that it casts a sharp shadow on the wall of the tube. This shows that cathode rays move in straight lines. When cathode rays are placed in a magnetic field, it never deflects towards north or south. It travels perpendicularly in or out. Cathode rays are 100% identical whatever the gas inside the tube. Cathode rays have the ability to move at a velocity of 1/10 the speed of light. It can also ionize gases as well as penetrate thin metal sheets. Cathode rays were named as electron by J J Thompson. So he was honored as the scientist who discovered electron. That is how scientists managed to isolate the atom of electricity, or simply the electron. In next video, I'm gonna explain how protons were discovered. Subscribe my channel and click the bell icon so you won't miss any future videos. This is Scienceorzo. See you in the next video. Goodbye.